Hello, welcome to our channel Cell Studies, and in this lecture we are going to discuss about valency. Okay, valency, and before we begin our lesson, subscribe our channel, like, share, and comment. Okay, now let us start about our discussion. The topic known as the valency. So, the first of all, what is meant by valency? Valence means combining power of an element. For example, let us say this is the atom A and this is the atom B. Okay, so both of these atoms are combined together by a bond. Okay, how the bond is formed? Bond is formed by the sharing of electrons. So this is the atom A, which has a one electron. Atom B has a one electron. So by sharing of these two electrons, the bond may form. Or otherwise, the atom A can donate two electrons to form a bond between the atom A and atom B. So this is known as the formation of bond. So here the valence electrons is going to play a major role in the formation of the bond. Okay, that we will discuss in the coming slides. Okay, especially as measured by the number of hydrogen atoms it can displace or combine. Displace means change, or it is going to combine with. Okay, that is known as the valency. So this is definition for the valency. Okay, so next is the in the valency we have to discuss the two important things. Okay, mainly almost three. Okay, three important things. So these two are the main important things, that is known as the valence shell and valence electrons. So what is meant by valence shell? So valence shell means the outermost energy level in the atom is known as valence shell. So for example, we have taken the chlorine. For your better understanding, I have drawn this diagram so that here the chlorine, here you can see the shells, shell 1, shell 2 and shell 3. Total, if you count the total number of electrons, there you will see the 17 electrons in it. Hence its atomic number is also 17. So here the electrons are distributed in the shells. Okay, so that is also electrons are present in the orbital. So that we have discussed in the last lessons. So here you can see the third shell is the outermost shell. The third shell is the outermost shell. Hence the third shell is known as valence shell. Okay, and next the electrons are present in the third shell. So these electrons are known as valence electrons. Valence shell means the outermost shell of an atom is known as valence shell. Valence electron means the electrons which are located in the valence shell, that is known as valence electrons. Okay, so next is the octet rule. So oct means 8, octa or oct means 8. So here this rule is something about 8. So what is that? It means any atom which has the 8 electrons in the valence shell, that is known as, that atom is stable. So for example, if you take here the chlorine, it has only 7 electrons on the outermost shell, so it is not stable. So for the stability or to gain the according to the octet rule, it need one electron. So hence this chlorine is going to take one electron from the sodium. So now it will get the 8 electrons in the outermost shell. So now it has 8 valence electrons. Now it is known as stable. So it is completely the stability of the electron, stability of an atom completely based on the octet rule. Each and every atom follows this rule except helium. Okay, so hence the elements try to lose or gain electrons during the chemical reactions to get octet electronic configuration in the outermost shell. So in the last lesson also we have discussed about electronic configuration, means distribution of electrons in the shells, subshells and orbitals. Okay, so the next topic is the formula to find out the valency. So what is the valency? Valency means the number of atoms required or number of atoms that has to be loose, that is known as the valency. Okay, each and every atom has the valency. Okay, whether it may be 0 or 1 or anything, it has the valency. So there are two formulas to find out the valency, the formula 1 and formula 2. So when we have to apply the formula 1, we have to apply the formula 1 for the atoms where it has the valence electrons are 1, 2, 3 and 4. So the formula says that the valency of an atom is equal to the valence electrons if the valence electrons are 1, 2, 3, 4. So now let us see how we have to apply this formula. So let us take the example of the hydrogen. Okay, hydrogen has how many electrons or how many valence electrons? Only the one valence electrons. According to this formula, if the any atom has the valence electron is 1, its valency is 1. Here you can see the valency of hydrogen is 1. So now move to the second, that is helium. The helium will not follow this formula. Why? Because helium is a noble gas element. Okay. Now move to the second, third one is known as lithium. So what is the valence electrons of the lithium? It is the one outermost electron, that is valence electron is 1. So hence according to this formula, the formula 1, its valency is also 1. Helium valency is, lithium valency is also 1. So next go to the beryllium. So in the beryllium, the outermost valence electron is 2. Okay, if the valence electrons are 2, its valency is also 2. Okay, now move to the boron, the third, 3 valence electrons. If the valence electrons are 3, its valency is also 3. So now move to the carbon, valence electrons are 4, so valency is also 4 according to this formula. So now the formula is satisfied to the electron to the atoms. So now move to the next second formula. So why? Because here is the nitrogen. Nitrogen has the 5 electrons, so the formula 1 is not applicable. So now we have to move to the second formula to find out the valency of the nitrogen. So what the formula 2 says, the valency of an atom is equal to 8 minus valence electrons if the valence electrons are 5, 6, 7, 8. Okay. So now see here, the nitrogen valence electrons are 5. So in that case we have to apply the formula 2. So hence you can do the some little bit calculation, that is known as 8 minus 5. So here the 8 is the formula. In the formula we have to take the 8 minus valence electrons. How many valence electrons are there? 5. So 8 minus 5, that is nothing but 3. So the valency of the nitrogen is 3. So go to the oxygen. So how many valence electrons are there? 6. Okay, the same thing. The 8 minus 6, how much? 2. The valency is 2 for the oxygen. So next to the fluorine. Fluorine has 7 valence electrons. So apply this formula, 8 minus 7, that is nothing but 1. So hence the valency of the fluorine is 1. So here coming to the neon, so 8 minus 8, 0. Okay, hence the valency of the neon is also 0. Okay, by this way you can apply the formula 2 also. Okay, so next sodium, magnesium, aluminium, silicon and so on, you can apply the same thing. Here we can see the same thing is repeated. So if the valence electrons of the atom is 1, 2, 3, 4, the valency is same according to the valence electrons. So here 1, 1, here 2, here also 2, here the argon 8 minus 8, 0, 7, 8 minus 7, 1, 8 minus 6, 2, 8 minus 5, 3 and so on. By this way, by using these two formulas you can find out the valency of any atom. Okay, and next the valency along the group. We know that in the periodic table we have the groups and periods. So here there is something with the group. The valency is something with the group, that is known as valency along the group. The group number is equal to the number of valence electrons of an atom except group 8A. Okay, 5, 6, 7, 8. This is a Roman number 8A. It has a 0 valency. So why? Because there are noble gas elements. Okay. So here you can see the group 1A, its valence electrons are 1. Okay, its valency is also 1. So here the group 2A has a 2, valence electrons also 2. So 3 has a 3A has a 3 and also valence electrons also 3. 4A has the 4 valence electrons, hence the valency is also 4 and so on. So here from here the 5th A you can see the 5 valence electrons and the valency is minus 3. Why? Because these atoms are going to gain the electrons, so they will get the minus charge. Okay. So the metals lose electrons for the stable octet electronic configuration. So we will understand this sentence with the help of the diagram in the next slide. So non-metals gains electrons for stable electronic configuration, that also we will discuss in the next slide. So the element becomes ions by losing or gaining electrons. So ions are nothing but when the atom loses electrons, then it becomes ion. So for example, let us consider this is the atom A. Example, we have taken the atom A. So here, if it is going to lose the electrons, if the electrons are lost, okay, so then it becomes the ion. So when the losing of electrons, what will form? It leading to the formation of ion. So it will get the positive charge. When the electrons are lost, it will get the positive charge. So when it will gain the electrons, when it gains the electrons, it will get the negative charge. So whether it may be positive or negative, it doesn't matter, but it is a ion. Ion may have the positive charge or ion may have the negative charge. So ion is charged atoms or element or molecule and has a charge on it. So whether it need not to be a single atom, it may be element or it may be molecule. Molecule means more than one, okay, A, B, C. So let us consider these are the molecules. So atoms means A or B or C. So these are individual things. Atoms are individual things and molecules are that these atoms are grouped together, are attached or joined together, leading to the formation of a molecule. Okay. So the molecule may have the positive charge or negative charge. It is nothing but atom or it is nothing but ion. Okay, ions have the equal number of electrons and protons. So in the ions, you will see the number of protons is equal to the unequal. It means unequal. What is meant by unequal? Unequal means not equal. So if it is going to lose the electrons in the neutral atom, neutral atom means the number of protons is equal to the number of electrons. So let us consider the atom A has the 10 electrons and 10 protons. So in that case, when it is going to lose electrons, what will happen? 9 electrons and also 10 protons. So here you will see there is unequal number of electrons and protons. So this such kind of unequal number of protons and electrons will be seen in the ions. Okay, and atoms are neutral when the number of protons is equal to the number of electrons. Example, sodium 11. So in the sodium 11, you will see the 11 protons and 11 neutrons, 11 electrons. So in this case, the sodium is known as neutral atom. So here in this case, we have taken only the outermost electron, okay, outermost shell. In the outermost shell, you will see the 11th electron. This is the 11th electron. So it is a neutral atom. Okay, in the previous slide, we have seen that there is always the metals are going to lose the electrons. So here you can see the sodium. Sodium has the how many electrons? 11 electrons. Okay, so it has to lose one electron. Why? Because it total in the outermost shell, when it is going to lose one electron, its valency is 1. So here you can see in this table. So the sodium, where is sodium? Here you can see the topmost is the sodium. Okay, the 1, its valency is 1. So it has the 2 electrons, 8 electrons and 1. Total how much? So total, so 8, 9, 10, 11. So 11 is there. But here what you need, here there should be 8 electrons. 8 electrons should be there according to the octet rule. But it has 9 electrons. 9 electrons are there. So as a result, to get stability, it has to lose one electron. If it loses one electron, the valence electrons are 8. So in this case, it has to lose one electron. So this one is the reason. Here you can see the sodium is going to lose one electron. So while the chlorine has how many electrons? It has 7 electrons on the outermost shell. So it has to lose these 7 electrons. 7 electrons has to be loosed or 1 electron has to be gained. So which one is easier? So losing of 7 electrons is much harder, so it is not going to lose 7 electrons. But gaining of 1 electron is much easier, so it is going to gain 1 electron. So it is going to gain 1 electron from the sodium. Sodium is ready to do 1 electron. Why? Because it has to lose 1 electron or it has to gain 7 electrons. So which one is easier? Losing of 1 electron is easier than the gaining of 7 electrons. So it is going to lose 1 electron. So as a result, this electron will go and bind over here. As a result, here you can see the sodium has donated 1 electron to the chlorine. As well, this chlorine is going to accept 1 electron from the sodium, leading to the formation of a ion. So that is nothing but Na plus. Why the plus charge came? Why? Because all the time when the atoms loses electrons, they gain positive charge. Okay, all the time when the atom receives electron from any other atom, it is going to gain and charge. Here the atom is taken, one electron is taken from the sodium, so it the chlorine has got the negative charge. Okay, so this is the thing how you can see in the atoms in the formation of molecules or ions. So the number of electrons are not equal to the number of protons in the ions, that is more or less electrons when compared to the protons. So here you can see the 11 protons has to be there, 11 protons are there, but how many electrons are there? So one electron is less. Okay, so here the number of next is the chlorine. So if you see the chlorine has 17, its atomic number is 17, so chlorine has a 17 protons, but it has a 18 electrons. Why the 18 electrons? Why? Because the chlorine gained one electron from the sodium, so the 17 electrons turned into 18 electrons. Okay, so hence it is known as an ion. The ionic bond is formed between the opposite charged ions, so that is nothing but NaCl. Why NaCl? So why we are calling it as ionic bond? Ionic bond is nothing but the atom A is going to, let us consider the atom A and atom B. So the atom A is going to donate one electron. So whenever you see the donation of electrons to other atoms, then there is a formation of ionic bond. Okay, we will discuss more about these bonds, formation of bonds in the coming lectures. Okay, and next we will see the cations and anions. These cations are the positively charged ions. Example, the sodium Na plus, K plus, and so on. Why? Because these are metals. All the time the metals are going to lose the electrons. So when they lose the electrons, you will see the formation of the positive charges over it. Okay. Next is the anions. These anions are the negatively charged ions. Negatively charged ions, that is nothing but example chlorine, oxygen, and so on. So they are going to accept electrons from the other atoms, whether it may be metal or any other thing. So they are going to gain electrons, so they will get the negative charge over it. Okay, so the elements try to lose or gain the minimum number of electrons for the stability. So if the atoms has to lose the electrons, so they are going to lose electrons at a minimum level. Okay, they are not going to lose electrons at maximum level. So for example, if you see the chlorine, so it is not going to lose electron, but it is going to gain the electrons. So sodium, example sodium, it is going to lose the minimum number of electrons, like one electron will be lost. So that's all, but it is not going to lose 8 electrons. Why? Because all the time according to the losing and gaining, so what the atoms are going to do? Atoms are going to lose or gain minimum number of electrons. So here also chlorine is going to gain only one electron. Okay, not more number of electrons. Just all the time these atoms are going to lose or gain electrons only for stability. That's all. Nothing about other things. They are going to gain or lose electrons only for the stability. The stability is nothing but octet rule. Okay, they need 8 electrons on the outermost shell. That's all. For example, Na plus, losing of an electron is better than the gaining of 7 electrons. Okay, so next only the valence electrons will be lost or gained. So in this topic. Okay, and this is the table. This table is going to explain about the valency, okay, electronic configuration, electron distribution, symbol, and also element and their atomic number, etc. Okay, so the valency plays a major role in binding of ions with other ions. Okay, so example NaCl, MgCl2, and so on. So here we have taken few examples, that is nothing but 1, 2, and 3 examples. So first example is the NaCl, the formation of NaCl. So the valency of sodium is 1, the valency of chlorine is 1. The sodium is going to donate 1 electron, the chlorine is going to accept 1 electron, leading to the formation of NaCl. Here both are ions. So both are ions formed after the donation and accepting of the electron. So in the same way, MgCl2, okay, magnesium chloride. So here the magnesium has the valency of 2. It means it want to donate 2 electrons for the stability. If the magnesium donates 2 electrons, it will get the octet electronic configuration. So as a result, it is going to donate 2 electrons. Hence the chlorine want 1 electron. So In this case, the magnesium is going to donate one electron to the two chlorines. So the two chlorines will come, one chlorine will take one electron, another chlorine will take another electron, leading to the formation of MgCl2. One magnesium, two chlorines. Okay. So here MgSO4 also. Okay. Magnesium sulfate. Here the magnesium is going to donate two electrons. Why? Because magnesium valency is 2. Okay, sodium sulfate valency is 2. So as a result, they are going to come together, leading to the formation of MgSO4. Okay, ions forms ionic compound. These all are the ions. Hence, after the binding with each other, so there is a formation of ionic compounds. Okay, and I hope this lecture is helpful to you. If you haven't subscribed to our channel, support us by subscribing. Provide your valuable suggestion or feedback in the comment section, so that it will help us to improve the content, and like, share the video. Okay, thanks for watching.